Hey, we want to go back over some of these complex numbers, some I values that hit. For example, in this first one, square root of 36, what if there is a negative sign underneath the square root? So if there's a negative sign underneath the square root, we have to represent it with what's called an I value, an imaginary number. So this negative sign gets represented as an I outside of the square root sign. So we've got negative sign underneath, becomes I value outside. We happen to know the square root of 36, it's just 6. And then you've got I times 6, 6I for a final answer. Now that's a nice one because 36, we know the square root of it. Not always the case. Sometimes we'll have to break one down. Like say we got 200. Let's say we have negative 200. Now, negative sign underneath the square root becomes an I value. So this is I, square roots of 200. Sneak over here. Let's run a little factor tree, kind of break this one down. 2, 100, 2, 50, 2, 25, 5, 5. So the 200, we break it down to 2, 2, 5, 5. And what you're looking for now is you've got the 200, you've rewritten it with 2, 2, 2, 5, 5. We start looking for pairs for two of a kind. Here is one pair of 2s, here is one pair of 5s. We're going to get them out in front. And if you remember the rule, 2 on the inside, you only write it one time on the outside. So this becomes a 2, a 5, an I. Looks kind of like that. And once you get them on the outside, you got to multiply it, clean it up. So this will be a 10I square roots of 2. Again, a negative sign underneath becomes an I value on the outside, 10I square roots of 2. All right, going back over all these complex numbers. So the imaginary numbers, 1, 2, 3. Let's do another one. Let's do nice and neat one. How about negative 9? All right, so when you walk up to this problem, you notice right off the bat there's a negative sign right there, which means we're going to represent it with an I that is outside of the square root. This one, we don't have to factor tree square root of 9. We know square root of 9. Square root of 9, that's 3. So you've got a regular 15, you've got a regular 3. Multiply them together. 45I. You're like, oh, I am digging that. Okay. 1, 2, 3. Ooh, let's do the I values. All right, hold on. So I to the first, I to the second, I to the third, I to the fourth. Okay, so at one point we had this memorized. Let's see if we've still got it. I to the first, that's just I squared, negative 1. I to the third, that's negative I. And I to the fourth, that's positive 1. So everything's based off this I to the fourth. All multiples of 4, I to the fourth, I to the 8th, I to the 12th, I to the 20th, I to the 40th. All multiples of 4 turn out to be a 1. Let's see if we remember how to do this. Let me teach you. 1, 2, 3, 4, 5. Let's say we have I to the 83rd power, and we want to simplify that. We always check to see maybe we'll get lucky and that's a multiple of 4. Like, will 83 divide nice and neat by 4? And it doesn't. If it did, you're like, oh, it's a multiple of 4, it'd just be 1. So we're going to split this into 2 i's. We just got to get our 2 powers. Your first power is always the closest multiple of 4 without going over. Closest multiple of 4. To 83, it's like 80's right there, 84's right there, but 84 goes over. So your closest one is 80. And then we need 80 plus something to give me 83. You're like, oh, okay, 83 minus 80, I got 3 left over. So 80 of it here, 3 of it there, total of 83. Now is the good stuff. Any multiple of 4, this one's a multiple of 4, automatically turns out to be a positive 1. You're like, oh. I to the third, we've got on our chart right here, I to the third, negative I. And then 1 times negative I, it's just negative I, that's your answer. It's always kind of cool, whatever ends up right here always turns out to be your final answer. Boom, boom, boom. All right, let's do one more of those. Got to keep this memorized. Here we go, 1, 2 through 5. I think that was 5, so this is 6. What do we got, I to the 29th? Okay, you always do a quick check to see if maybe 29 is a divisible by 4. 29 divided by 4 nice and neat? No, it doesn't. So we got to split this into 2 i's and find our 2 exponent powers of each I. Your first job is to get the closest multiple of 4. Like, is 20 the closest? Nah, 24 is closer. Nah, 28's closer. 32 goes over. So 28 is your closest multiple of 4. But we still got a little bit left over here. You're like, okay, 29 minus 28, 1 left over. Boom. And then you can check 28 plus 1 is 29. So you split it into 2 parts. This one is a multiple of 4. Every multiple of 4 turns out to be positive 1. I to the first, we check our chart. It's just I. And then this guy's always your answer, whatever this is. Boom. So 1 times I, that's I. That's all she wrote. Ha ha ha. Okay. So, those are good questions. Pays off to have this memorized. All right. Number 7. What do we got here? Oh, a little multiplying. All right, let's do a little multiplying. 7 minus 2i. What's next? 8 plus I. All right, got to distribute. You've got a 7 that hits both of these, a negative 2i hits both of those. So multiply the 7, multiply the negative 2i. 1, 2, 3, 4. 4 tiny little math problems. Give us 4 math answers. So 56 plus 7i minus 16i minus 2. I squared. Oh, I squared's jumping on. All right, let's clean this up right here. You do have some like terms. Positive 7, negative 16. Was that minus 9i minus 2, I squared. All right, check it out. I squared, anytime you have I squared, you can replace the I squared, negative 1. I squared, negative 1. I squared, negative 1. I squared, negative 1. There's I squared. We're going to replace that with negative 1. Ho, ho, ho. Oh, negative times negative becomes positive. And now you've got a 56. You've got a positive 2. Add them together. 58 minus 9i. See if we can get that to fit on there. Just barely. All right, pretty good question. Had some like terms put together. Had to squeak in an I squared. Not too bad. Eight. Oh yeah, okay, one of these. Another multiplier. So same setup. We do have a little trick shot that's getting ready to happen right here. A little trick question. Let's go ahead and distribute 10 times 10. 10 times 3i. 3i times 10. 3i times 3i. So again, you got to distribute. You've got 4 math problems in a row. 10 times 10, this is 100, plus 30i, minus 30i, minus 9 times I squared. All right, it's real similar to the last question that after you multiply, you check right here in the middle, but what happens on this is the trick I was warning you about. A positive 30, negative 30 cancels out. So these, they gone. So we've got the 100 still left, we got the minus 9I squared. You just wrote down I squared, and it dawns on you, I squared always equals -1. You're like, I can put in -1 in place of the I squared. Negative times negative becomes positive 9. And then to finish this off, looks like 109. Dun, dun, dun. All right, guys, that's 8 examples. Let's do one more. Let's do a little adding, subtracting of some like terms. And then we will sign off. One more example. 9. What do we got here? 12I. Oh, not 12. That's a 20. My fault. So 20I minus 7 minus 8I plus 3. All right, got some adding and subtracting. So the standard trick, you've got the negative sign out in front of the parentheses. It's going to hit both of those. So this negative times that negative becomes a positive. All right, like terms together. You got your 20I plus your 8I. Let's rearrange. That's fine. Minus 7 plus 3. Like terms together. 20I plus 8I. That's 28I. Minus 4. I values, regular numbers. All right, so be careful on this one. A negative sign hits the 7. -7, but negative times negative becomes positive. All right, guys, going back over all those operations that involve complex numbers, imaginary numbers. There you have it.